floor is yours.
Thank you for the introduction and good afternoon, everyone. So as you heard, my background is actually in computer science. It's not theater, it's not music formally, unfortunately, but it's not rare that at the Faculty of Computing and Electrical Engineering, people have different interests, and then they tend to combine those interests with computing or electrical engineering. For example, I had a friend who was interested in medicine, and then he ended up with biomedical signal processing or similar topics. So my story was similar. I have been always interested in music. So I tried to combine all these approaches related to computing, including signal processing, machine learning as well, with music. And then in course of time, I learned that there is a nice mix of those practices, which is actually computer music, something that is made by computers. And usually when we think about computer music, probably we have association with something like this. This is actually one of the first recordings made during the 60s at MIT using PDP-1 computer. And the reason why we have such associations is because usually we think that, okay, computer can produce sound, but we still need composers to do everything else, to select notes, to structure these notes into some kind of phrases, and then to create an overall composition. And then during that time, when computer music actually started to grow and the research was more and more prominent, then this notion of time scales of music encountered as well. It's introduced by Curtis Rhodes. So now with computers, we can also affect not only on the note level, so not only to choose which notes we would like to hear, but also we can compose timbre. We can go on smaller scales of time, let's say like that. And on the other hand, also computer can run for a longer time than orchestra or a human before becoming tired. For that reason, it's possible to see a broader perspective in terms of the scales of music. And when it comes to computer music, then it's not only about timbre, it's not only about synthesizing the sound, but also about like algorithmic composition, which can be used for automatic selection of sound objects and musical tones, or creating structures, interaction, and so on. And for that reason, actually, I skipped those examples. There are a lot of nice examples how sound design and computer music in terms of this quality of sound can be used in theater. I actually found, but due to the lack of time, I wanted to focus on other time scales in terms of the use of computers in order to achieve something else, and maybe not only related to the musical content, but also to the conceptual content of the performers, or on the background in terms of data that is used, or something like that. So I would like to start on the level of algorithmic composition, which is actually quite broad, and it's not focused only to computers. So the idea of algorithm is actually just the procedural sequence of steps. So if anything, you can write like a recipe, take this, do that, then it's an algorithm, even though it sounds fancy when it's mentioned in the context of computing and computer science. However, already in the 15th century, there was a canon as a musical form that is actually also some kind of algorithmic composition. And also during the time of Mozart, there were automated composition techniques in musikalisches Würfelspiel. So it's a dice game where people threw dice and then selected phrases of music and stuck them together. But with computers, the ranges of possibility, of course, expanded. And if there is a certain mechanism that can create music, either based on stochastics or the rules, or on some kind of statistics that are learned from existing music material, it's all considered as algorithmic composition. So it's quite a broad context. In several next examples, I will show you how this can be used in a connection with some kind of performance which is not just musical. So the first example is my quite old piece, which is actually more like a game for clarinetists and computer. The motivation was the memory game. If you remember with those circles, so first you would see a 1, and then the second would be added, third, and so on. And then the player would need to repeat the whole sequence, remember the sequence. And for a clarinetist, for me, it was interesting because on a clarinet, you can get the same tone in different types of fingering. And then it was not only about remembering, but also how the player will interpret this melody just after seeing one note. So this is how it looks like. And this is actually just recorded from a rehearsal, but we had also a performance in the theater environment. There's also some kind of sound design developed by algorithms for sound synthesis and granular synthesis, as well as a background. However, everything else is automatically generated. Clarinets can see only the last note, and the sequence is constructed automatically during using a Markov chain. And then I have maybe this is the most mainstream example that I will show today. It is on a higher level actually, because it's a musical that was performed at West End, which is somehow composed, not completely, but mostly by computer algorithms. It's very conventional, mainstream musical. The plot was written by human artists. However, the computer was used to generate harmony, melody, rhythm, and everything. So that was 7 years ago in 2016. Until then, the technology immensely improved and changed. So nowadays, this is, I would say, possible even without so many interventions by human composers. Just to give a sense of how it sounds, here is a short excerpt of
Every time we stop a vehicle from entering the base, we're saving the world and preventing the extinction of our race. Every time we're on the news of the women here.
It is called Beyond the Fence. And nowadays there are algorithms that can learn based on existing material. It was also possible back then, but usually then the algorithms use the symbolic notation of music, like if you're familiar with MIDI or some kind of format that can contain information about musical notes. And nowadays, actually, the algorithm can learn directly from sound without knowing the concept of notes, the concept of instruments. So on each individual sample, so a small piece of information, which is like 4,000 times per second, you get one sample. And then the algorithm can learn to create music that is consistent for minutes or maybe even more. Based on textual input or some kind of parameters that are used for conditioning such algorithms. And then there is a very specific case of algorithmic composition, which is sonification. And it is actually a translation of data to sound in the same way that you could visualize data, because we can detect and understand colors, shapes, and so on, but we can also hear frequencies, loudness, and so on. So sonification is also a very broad term. It doesn't always used only for artistic purposes. It can be used for alarming, for observing data, and so on. But if it's used for artistic purposes, then it can be very interesting. So the first example here is my piece focused on mapping data from advertising server. So when you browse internet, you see all those ads jumping around, and those ads actually are served based on all different information that your device provides. For example, geographical location, type of device, time of day, and so on. And then this is one example how those data can be mapped directly to sound without much interventions. And the visualization is done by my colleague Antonija Pošić, which is also quite direct. So what is specific here is that every click on the ad is mapped to a very short sound object, which is almost beyond the perception of threshold, in a way that you wouldn't be able to hear one click, but when you put thousands of them together, then you see, you hear the texture. And now, when this concept is further generalized, it can be used not only to sonify existing data sets, but also to sonify, for example, movement. And there are really nice works that are actually exploiting on this idea. One example is this, the next one, which I will show, which actually measures proximity between people without wires, without visible devices, based on like the capacity between them, and then it's transformed to sound. I think this is a very nice project. They made several performances, also workshops, therapy based on this system, which is called Synthia. The next example is a performance called Doors of Perception. This example is actually based on computer vision. So there is a camera on the ceiling, which is capturing the location of the dancer. Based on the location, the sound is parameterized. The composer is Srđan. And this is a very, very simple example in which only the location is detected. Nowadays, we can extract a lot of information from image, for example, emotion from the human face. That was a concept for one performance, but we didn't use this specific algorithm. However, it's just one example how computer vision can be used to somehow create interaction with music. The sounds that you heard were composed using live coding environment. That means that I wrote code in real time in order to manipulate with different sound sources and parameters of a sound synthesizer. So this technique is nowadays quite interesting, and it's an emerging field of computer music in which it's more somehow associated with the club scene, with dance music and so on. However, it can be also used for experimentation with different types of sounds. So my idea was always to use my own set of samples to create aesthetics that is unique, and otherwise it would be very hard to create such sounds manually. I think that computers are actually interesting, especially for such purposes. I also used the live coding for another contemporary dance performance in which I noticed that actually with such live control, it was possible to have a small level or a nuance of surprise, both for dancers and for me. I had blocks of code written in advance, but each time I would change something and then save for the next time. And this was how I saw the dancers in performance, because I had coded and manipulated during real time. And to end the presentation, I would just like to play a short excerpt from the performance. Okay, thank you very much for your attention. If you have any questions, please feel free to catch me later or contact me on email or Instagram. Thank you very much.
Thank you.